You got this.
Okay, single replacement, folks, that is with a combination decomposition, so this is the third type of reaction that we're gonna discuss. The general format is when you have an element that is by itself, like in this case, A, that reacts with an ionic compound. So if you see like here, this is an example, zinc would be your A, the element by itself, that reacts with an ionic compound. B and C are the ion. Silver would be your B, NO3 would be your C, right? So the cation followed by the anion. So in a single replacement, what happens is that the element that is by itself will switch the other element that is in the compound, one of the ions. If this is a metal, we'll replace a metal. If this would have been a non-metal, it would have replaced the anion that stands on the side of the non-metal. So if I am to write this here, and I'm replacing zinc with silver, zinc will combine with NO3. So I'm gonna write the zinc followed by the NO3. We're gonna make a compound. Anytime you write a new compound, you have to do the charges if this is an ionic compound. Zinc has a 2 charge, NO3 has a -1 charge. So basically, you need the 2 at the bottom of NO3, right? And then silver will be kicked out of the combination. So silver will be going by itself. Okay? So this is the way it works. So of course, this is a reaction that has to be balanced. If you look at the nitrate, you have 2 here. Here you have 1. You fix that by balancing this reaction, this compound, and then 2 silvers here. Okay? So this is your single replacement. How do you recognize it? You have an element by itself and a compound. Okay? So now, we have different type of single replacements. So I'm gonna break it down into the types, into two major types. Let me go to the next slide. So type 1, and I'm gonna introduce this to you as if we were talking about people dancing. How about that? Okay? So type 1. Type 1, a metal is by itself, replaces metal or hydrogen in compounds. Okay, so the first category in type 1 is metal by itself, replaces the metal. And the second would be a metal by itself replaces hydrogen. So we're gonna have an A and a B situation here. So let's take an example. So I told you I'm gonna do this like a dancing thing. So imagine that you're going to dance, and then Johnny, which is a metal, Johnny dances, and then next to him is I don't know, give me a name. Give me a boy name. Oliver. And then the dance is with Mary. Johnny is the metal, and Oliver is the cation, and Mary is the anion in an ionic compound. Also, Oliver is also a metal, John is also the metal. Boy and boy, right? Okay. Now, what happens is that Johnny wants to dance with Mary. Okay, so he wants to kick for Oliver to the side. Okay. Now, this is going to happen only if Johnny is stronger or richer or more handsome than Oliver, because Mary is stupid. Good? So how is that going? How are we gonna look at that? We're gonna look at the activity series of metals. If Johnny that is by itself, the metal by itself, if he is above the metal that is combined with the non-metal in a compound, like Oliver in this case, then Johnny will replace Oliver. If he's underneath in this list, Oliver stays and dances with Mary and nothing happens, no reaction, okay? So let's assume that Johnny is stronger than Oliver, so Johnny and Mary are gonna keep on dancing together, we're gonna dance, and then Oliver is gonna kick to the curb. So Oliver. So in this case, let's say that Johnny is potassium, and then Oliver will be sodium, and Mary will be chloride. So in this case, you compare potassium and sodium, you compare the two metals. Is potassium higher than sodium? Yep, it is. So potassium will switch with sodium, and you're gonna have potassium chloride That's the new combination, and then sodium goes by itself, sodium being your oliver. Good? Now, in a chemical reaction, can you switch the products? Can you say Oliver first and then John and Mary? Yes, you can. You can write Na plus KCl. It doesn't matter. Here you can write NaCl plus K. It doesn't matter as long as they're put in the reactant side correctly and in the product side correctly. Good? Okay. This reaction is balanced, no issues about that. So far, so good? Now, what if Johnny is below Oliver? What if Johnny would be, let's say, sodium, and Oliver would be potassium with chlorine and react? You compare sodium and potassium, and you see sodium is below potassium. That means sodium is not strong enough to push potassium out of the compound. So it's going to be no reaction. You can have these two sitting together in the same environment, in the same test tube, in the same beaker, in the same whatever, and nothing ever is going to happen. Okay, so we have no reactions. This activity series of metals is something that you have right here, so pass it around. This. Just give it to me. This table at the top, and for the people that are doing it online, you have to print it out. It's one of the worksheets of the handouts that they have there. So this top, here you have, it's used only for single replacement, okay? This is only for single replacement. You have this situation when you have to check the activity series of metals, okay? Now, I want to point something out to you. In this series of metals, in this activity series, you have hydrogen at some point. Hydrogen is not a metal, but hydrogen can act, because he makes H plus, the cation. Hydrogen can act as a metal, not act as a metal, but makes a cation like a metal would be in an ionic compound. So the second situation here, B, would be if Oliver is hydrogen. So in this case, you have metal replaces hydrogen in a compound. What compounds can we talk about? Acids, they start with hydrogen, or water, it starts with hydrogen, okay? So metal plus water, or metal plus an acid, that means metal replaces the acid, the hydrogen, if the metal is above hydrogen on this list. So if I'm having something like this, I have let's say sodium that reacts with hydrochloric acid. You compare sodium, which is up here, and look at hydrogen, which is down here. So sodium will switch with hydrochloric acid. So sodium switches the places. You're going to have sodium chloride, and then hydrogen, like H, will turn into H2 because it's a diatomic molecule. Good? Okay. What if you have, I want to say, magnesium that reacts with sulfuric acid? Okay, magnesium is above hydrogen, okay, it's going to switch. So you're going to have magnesium that combines with SO4 now, and then hydrogen goes by itself. So the 2 for hydrogen here and the 2 for hydrogen here, they're not. So you don't take these two and put it automatically here, that's what I'm trying to say. The 2 here is because hydrogen is diatomic molecule when it's by itself, and here, this 2 is because sulfate has a charge of -2 that crosses over. Okay, even if you have one hydrogen, it's still gonna be H2. So that is the situation when Oliver is hydrogen. Okay, so you're gonna have an acid. And the third situation when Oliver is hydrogen would be when you have metal and water. Water starts with hydrogen, but for water you have to remember one thing. That water in this case, we need hydrogen to be a cation. We're gonna write water as HOH. So only the first H in water gets switched over. This is the cation, this is Oliver. This is the OH, this would be your Mary. Because OH has a minus charge, right? -1 charge. So when I have to do this, I am not replacing all the hydrogens like I did for the acids. Here, H2SO4 had 2 hydrogens, I'm gonna replace them all. Here, with 1, I'm gonna replace it. If I have phosphoric acid, H3PO4, I will replace all the hydrogens. So So here I would have nothing with hydrogen. Hydrogen would be here as a gas. In this case that we have right here for C, your metal reacts with water, and I'm gonna write HOH instead of H2O just to make it, just to show you, to make it see better. H replaces this, sodium replaces this first H. So you're gonna have sodium hydroxide, NaOH, and hydrogen gas. H2 still comes out, but you're gonna make a hydroxide here with this OH. This is Mary, and this is Oliver, that we have here. Okay? Now, what if your element, your metal by itself, will be underneath hydrogen? What's gonna happen then? If you have copper and water, or if you have copper react with hydrochloric acid, or copper react with any other acid, nothing happens, no reaction, okay? Because these metals are less reactive than hydrogen. They cannot replace the hydrogen in your combination, okay? That's why they make the plumbing out of copper. Because if you put water on top of any of these, they're gonna start reacting sooner or later. Put water on top of sodium, you're gonna have an instant reaction. You put it on top of aluminum and zinc, you're gonna have a later reaction, but you're still gonna have the process happening. You put it on top of these metals, that's the silver, gold, and all these that are noble metals. That's why they're noble, because their reactivity is very low, and they do not react with the environment so quickly. Okay, so that is the first case, the type 1 of single replacement, when a metal can replace, Johnny, can replace another metal or hydrogen, which is in an acid, or hydrogen that is the first H in water. Good? Okay. Now, the type 2. Type 2. Single replacement reaction. Let me go to this. Okay. Type 2 single replacement is when you go dancing, and Mary is by herself, a non-metal. Remember that I made the girl be non-metals here. And then you have, let me make Jane. And then you have Oliver and Mary still dancing. Now Jane has her eyes on Oliver, and she wants to kick Mary out and dance with Oliver. Okay, so this is a non-metal that has to replace the other non-metal. In this first case, you had a metal that had to replace the metal, right? Now, this is the funny thing, and we're getting into a little bit weird. Jane and Mary are first cousins. They belong to the same group, and all this happens only with elements from group number 7 that we call halogens. These are fluorine, chlorine, bromine, and iodide. And the order of elements in the group is the order of reactivity. Whatever is at the top replaces everything underneath. Okay? So in this case, my Jane would be, let's say, fluorine gas. And all these are diatomic when they're by themselves. Okay? Fluorine gas, and then I want to replace, I want them to react with aluminum chloride. Always make sure that you match. If this is fluorine, look for the element that is in the same group with it. If you want to replace aluminum, you're making a mistake, because non-metal replaces the other non-metal, not the metal. Only the metal can replace a metal or hydrogen, but the non-metal replaces the non-metal. So in this case, fluorine is above chlorine, okay, so I'm gonna make the switch. So I'm gonna put aluminum now with fluorine together to make aluminum fluoride, and remember the charge is 3 for aluminum drops here. And chlorine will go by itself. When it goes by itself, it turns into a 2. So always remember, do not carry these subscripts from one side of the reaction automatically on the other side. You always have to do charges to figure out the new subscripts, or you have to remember the diatomic molecules, okay? So in this case, I have 2 fluorines with 3 fluorines. I want to make 6 fluorines on both sides by multiplying this by 2 and this by 3. And here I'm going to make 6 chlorines on both sides by doing this, and to balance the equation, okay? So two type of single replacement. Type one, metal, that takes care of a metal or hydrogen. And type two is non-metal from group seven, which is called a halogen, that replaces another non-metal from group seven, the same family, okay? Which is called, also a halogen. Now, what if, so don't make this mistake, I've seen people making this mistake, let me find my different color. If you replace it like this, say, okay, I'm replacing the first, because that's what you understood, and that's wrong. So if you have something like, F2Cl3 and then aluminum, some stupid stuff like that. That is incorrect because this is not, and the aluminum doesn't come out. So replace, do the proper replacement. This is incorrect. The non-metal has to replace the non-metal, not the metal. Good? Now what if I have chlorine by itself that wants to react with aluminum fluoride? What's gonna happen here? You're comparing chlorine and fluorine, and according to the reactivity in the group, it's gonna be, like he said, no reaction and on. Okay? So this is your single replacement, and that's it. That's done. Okay?